A thermodynamic process is a series of changes in a system state, involving energy transfer as heat and work. These processes follow the laws of thermodynamics and can occur in different ways based on how heat, work, and internal energy interact. The first type is the isothermal process, where the temperature remains constant, meaning T equals 0. In this process, heat is exchanged with the surroundings. An example is the slow compression or expansion of gas in a container with good thermal conductivity, and it follows Boyle's law. Next is the adiabatic process, where there is no heat exchange, so Q equals 0. Here, energy transfer happens only as work. An example would be the rapid compression or expansion of gas in an insulated container, and it follows Bresson's law. The third type is the isobaric process, where pressure remains constant, meaning P equals 0. In this case, heat added or removed changes the volume and temperature. A common example is water boiling at atmospheric pressure. Then we have the isochoric process, where the volume remains constant, meaning V equals 0. In this process, no work is done, instead, heat changes the internal energy. An example is heating gas in a rigid container. The fifth type is the polytropic process, which is a generalized process that follows a specific equation where a variable changes. An example of this would be practical thermodynamic cycles like engines. The sixth type is the cyclic process, where the system returns to its initial state and net work is done over the cycle, which is used in heat engines. Lastly, we have quasi-static and irreversible processes. Quasi-static processes happen infinitely slowly to maintain equilibrium, while irreversible processes include real-world factors like friction and turbulence.